Okay, yes, to be intellectually honest on this problem a little bit to get it down correct. Right, so we've got this this is the pattern, right? This is the actual diffraction pattern. These are the light bands. And I think, is everyone here comfortable with the fact that xm is the distance between light bands? No matter how, what made those bands, this is the distance between them. And then if I had paid attention to the given information, which I should have, then I would have noticed that L is 0.25. So already we've got something where we have an L, or a distance from the screen, and we have an XM. That already locks me into like one sense of logic, but, well, I mean, one equation, which is this. Right? And then, of course, the D here. So when we remember this equation, obviously xm we said is the distance. M is going to be n equals 1 for a diffraction grating. Lambda is obviously lambda. L is the distance to the screen. And D is the distance. Remember when we used this for a double slit diffraction? D was the distance between the slits. So how do I find this distance when I'm told that there are 1,000 slits per centimeter? Right? Well, all I need to do is say, okay, that's going to be 1 times 10 to the 5 slits per meter. And if I invert that, I get 1 times 10 to the minus 5 meters per slit, which is in fact D, right? That's a distance between them.
Wait, N is 1 for diffraction rate?
Yeah. Because, okay, it's a good question. Why is N equal 1? If we do a single slit, or if we do a double slit, the pattern, the light pattern over here, right, this light pattern, every one of them is caused by just those 1 or 2 slits. So then these become like, it's like they're farther and farther away from the central maximum. Okay, but on a diffraction grating, as long as your light source is consistent across the front, which we're assuming it's just a solid wall of light hitting the diffraction grating. What's that? Yeah, XM is always the same distance. Even if you're talking about these, XM doesn't fade away. That's why. Oh yeah, remember the other day I was trying to show you this with the water. It's because of dampened oscillations. That's the reason that the distance kept getting smaller. It's because these waves are not mechanical. These waves are like light. They're energy. So they don't dampen. But a mechanical wave dampens. Like it loses energy as it goes. Not only does it like, so that change is what was reducing the thing. So that's why that didn't work. So yeah. Remember, I'm sorry. I told you I'd figure that out, but then I forgot to tell you. So these diminish as they get farther and farther away because there's less light coming from the one slit. But do you see like these are pretty much the same all the way across the board because there's like an infinite number of slits. So it's like just a million of these next to each other. So N is always 1. Because you're not getting like, this is the first, one, and then like you're going to the third. No, because there's another one right there. So every single band is caused by like 2 slits. So it's like maybe rather than this one, you can think of it like this. There's 2 slits for every single one of these, so N is always 1. Does that make sense? No, not like if there was an infinite number of double slits, right? There's always 2 slits or multiple slits in front of every single one of them. So you can always easily just say N equals 1. I mean, it's probably the case that in reality that there's some like effect on some of the other ones, and then as you see in the picture, there's probably in that picture there's the light is more intense in the middle, and that's why one of these was brighter. But in general, like they're all the same distance away from the same number of slits. But with that, yeah, and so with N equaling 1 or M equaling 1, as the case may be, then lambda is XMD over ML. Oh crap, are you kidding me? All of that didn't record. I thought it recorded. Anyways, just use that equation. Okay, explain that.